So I'm going to be talking today about genetics, and some people get nervous when they hear about genetics because it's fairly complicated. But I'm not a geneticist, but I've been very lucky that I've worked with people who are very good in genetics, and so what I try to do is I try to simplify it for me, so if I understand it, then you should be able to understand it. And I'm going to be talking more about the practical application of what it means, rather than getting into the nitty-gritty and the details of genetic research, okay? So don't get nervous about what I'm going to be talking about. I'm going to try to keep it as practical, but based on theory. So starting out, this is the topic, and I'm using obesity as an example because when we talk about lifestyle diseases, which is most of our problems, we have genetic disease, but like if you don't have a particular gene, you can have cystic fibrosis. But the majority of the problems that we have are lifestyle diseases, and genetics plays a role in that, but it's not that, you can't just, but you'll have 10,000 people who live this way, they'll die earlier than 10,000 people who live that way. But you can't, there's no microbe or bacteria or virus or anything that's connected to those. So genetics and the environment play a role. We have genetic and non-genetic factors. So the genetic factors is your background, and the environment is the lifestyle factors. So the genotype, just a couple of definitions. The genotype is your genetic background. What is the gene structure in your body? The phenotype is how that's expressed. So it could be, I have a blood pressure of 120/80. I'm 5'8". I have a VO2 max of 50 ml per kilogram. Those are all phenotypes. That's how your genetic background is expressed. So there are two kinds of effects. One is how you are now and how you respond to a stimulus, okay? And I'm going to be pointing that out a number of times. That's why I make this very large so you understand this. How you are right now is, if I measure you, what's your height, what's your weight, what's your blood pressure, these things. I'm looking at those phenotypes. Then I give you a program, either exercise or medication or diet, to change something, and then I see how you respond. And genetics will affect both of those things, because we have found through research that there are high, average, and low responders. Now, you all know, we talk about it in terms of diet, medication, and exercise. Now, a person can go to the physician and say, I have high blood pressure. And the physician says, okay, take 10 milligrams, and they get a response. The next person comes and says, I've got the same problem, but I have to give you 20 milligrams to get the same effect. The third one comes in, that medication doesn't have any effect, he has to do another type of medication, okay? Same thing with diet. The doctor will say, go on a diet. Some people come back, they've lost weight, others have not lost any weight. And the doctor says, you must not be doing the program. No, maybe they're a low responder. And I'm going to give you examples of that as we go along. So the genotype not only affects how you respond, how much you respond, but how fast you respond. So some people will lose weight, for example, and lose a lot right away. Others take a long time. Same thing with training. Some people improve greatly, and some people don't improve very much, or they much more slowly. So we look at the interrelationship here of the genotype. That's your genetic background. It affects how active you are. It affects how fit you are and how healthy you are. That makes sense. And how active you are affects your fitness. Your fitness affects your activity. Activity affects your health. Your health affects your activity, your fitness. So those are all interrelated. But the interesting thing is that the genotype also influences how much physical activity and fitness affect each other. It influences how much your activity and your health influence each other. So the genetics has a role to play in that sense. Now, the genetic influences tend to be stronger on structural components. How tall you are, how wide you are, what's your waist circumference, that sort of thing. That tends to be more genetic. Whereas the function is more influenced by environmental factors. And I'll give you an example. How tall you are, how big your muscle is, how big your waist is, how tall you are is a very high genetic component. But this is a little bit lower because I can increase the circumference of my biceps by lifting weights. I can increase or change the circumference of my waist by the environment. I eat more, I eat less, I can gain or lose weight. So it's still there's a genetic influence, but it's not as strong. Okay, the same thing would be if you look at muscle size. Some people have just start out with large muscles or very thin muscles. So that's, and the fiber type and the strength, because they're all related, that's a very high genetic component. But when you get down to what kind of enzymes are there or how many mitochondria in there, because that's related to how well you're training, that's lower, that's much more environment. So what you're always trying to do when you do genetic research, you're trying to say what is genetic and what is environment. Okay? Because those two influences are usually always there. Give you another example. Your BMI, the relationship to height and weight, is low. The height is a high one, but your weight, that fluctuates a great deal more due to the environment, so it's less genetic. How much fat you have is low, because that's a lot about how much you eat and your environment and that sort of thing. Percent body fat and the fat mass is moderate, and the pattern of distribution has a genetic influence. So if if your parents, your mother, for example, has a body fat distribution, a certain pattern, the daughter will have many of them will have a similar pattern. And so the pattern of where the fat is located has a little bit more genetic, although it's not all, it's just moderate. Now, so if we talk about obesity and genetics, the risk of having an obese child, if one or more parents is obese, is 2.5 times the risk of when both parents are normal weight. But is that genetics or environment? I ate what my mother cooked. And if she ate a lot, I ate a lot. And so it's a little bit of both. So if both parents are overweight, you have a better chance of being overweight, but that may be because of the environment and not necessarily just because of genetics. But there's a familiar resemblance of how much you eat. If the parents, the spouses, the parents, and the children. Like I said, I ate everything my mother cooked or else, right? But she was a good cook, so I didn't mind. But how much I eat and what I eat is genetic, possibly, and also environmental. Lifestyle and environment has a minor effect in how many the calories I get from lipids and fats and carbohydrates. Interesting, though, if you take monozygotic twins, I'm going to explain about twins. You have what's called monozygotic or identical twins, and you have dizygotic or non-identical or fraternal twins. A identical twin has the exact same genetic background. So that's a person, two people in duplicate. Whereas the fraternal twin can be two brothers, it could be a brother and a sister. And so they have a similar genetic background, but not an identical one. So if you do the people who are identical, their diet will be more similar than the fraternal twins. And there have been studies on monozygotic twins who were separated early in life. Let's say the mother and father divorced, and the father takes one twin here, and the other twin is over here. 20 years later, the twins get together, and they have similar diets. They have a lot of other things that are similar, which says that their genetic background has an effect on that. Because so there are a lot of research comparing identical and non-identical twins, and I'll show you some of that. So many obese people do not have obese parents. It's about 25% to 40%. But the majority of the phenotypes, it's very low. They're probably, at the last count, over 50 genes that have been associated with obesity. All right? But it's not affecting, the pharmaceutical companies would love to be able to get a gene, something that would modify that gene. But that one gene is only affecting 3 or 4% of the population. It's not affecting everybody. And so what you have is you have the gene that has to be there maybe, then there's a gene reaction with the environment, then there's an interaction between this gene and that gene. And so you have so many combinations that it's very difficult to say, I modify one gene and everyone's going to lose weight. Okay, so it's an idea, and I'm sure some pharmaceutical companies would say, hey, if I can help 4% of the obese people, I'll make a lot of money anyway, because we got a lot of people who are like that. This is a study in which they looked at the genetic predisposition, and what they did essentially was they said there are, and at the time they did this, there were 17 different genes that were associated with obesity. So it said if you have less than 6 of these genes or more than 17, and this was the distribution, it's a fairly normal distribution, here's the more genes you have that are associated with obesity, the heavier you are. This is at the same height, and then this is the weight at the same height. So you see it's that way. Interestingly though, the people who are active still have that relationship, but it's lower. The people who are sedentary have a higher. So they have the same genetic predisposition, but because they're active or inactive, their weight is higher or lower. So what this means is, even though the patient or client may be predisposed to obesity, physical activity still can help. So that's the environmental aspect of it. But there's a genetic aspect. Now, what about genetics and physical activity? From the Framingham study, the ratio of the effect of parents' activity level on the children's activity, if both parents are inactive, it's 1. If one is inactive, the other is active, it's 3.5 times greater of being active. And if both parents are active, it's 5.8 times greater that the child will be active. All right? But again, is that genetics or is that environment? If your parents are active and they go camping and they go hiking and they go skiing and they take you with you, and you do all of these things together, is that activity or environment or some combination? All right? What is the evidence that genetic factors influence activity? Well, if you look at twin studies, especially with monozygotic or identical twins, it can get up fairly high. With the fraternal twins, it's not as high. If you look at family studies, it's only 15 to 30%. So physical activity is more behavioral than genetic for most people. What about genetics and fitness? Well, there are people who are genetically more fit but less active, and there are people who are genetically less fit but more active. So you could have a person who genetically, without doing a lot of activity, has a high VO2 max or is very strong. Another person doesn't have this genetic background, but is training hard and trying to increase the strength and trying to increase the endurance. They may have the same VO2 max or the same strength, but they started out differently. So they may have, but you can't predict one from the other. You can at the extremes. If you're really active, you're probably reasonably fit. If you're really sedentary, you're probably not very fit. All right? But in the middle, you can't predict one from the other. So I just say, I'm fit. Oh, you must be active. No, I don't do a damn thing. Well, you've been trained like crazy. You must be fit. No, unfortunately, I'm not. And so you can't go for the majority of the people. So what about genetics and training? Well, if you take identical twins and you train them, they tend to start at the same place. Remember where you are now, that genetic effect? They start at the same place and they respond in a similar manner. But if you take non-identical twins, they'll be different where they start, and they'll be different in how they respond. So that tells you if they start the same and end the same, there's a genetic influence. But that's only on the people who have the same genetic background. The ones who have a similar background, it's not. So the non-identical twins will vary much more in their fitness and how they adapt to training. Let me give you an example. Just going to look at this one here. This is twin A and twin B. The changes in monozygotic twins in their VO2 max. And what you see is, here's one twin pair. This is twin A and twin B. Neither twin improved. They trained, but neither one improved. That would be definitely a low responder. Then you have another group where this one improved 12%, this one improved 14%. They're much more similar. And you see that they're very, very similar. If you'd had non-identical twins, it wouldn't be as much. It would be similar. Would be the correlation, instead of say 0.7 would be about 0.3 or 0.4, which is not that strong. This is looking at identical twins, their strength increase in 1 RM max after 10 weeks of strength training. And again, you see, here's one twin and his brother. And you see, this is the mean of the study. This is not individual. That's, each one of those dots is a different study. And you see, there's a lot of people here who have 80% improvement here, 75% there. They're very similar, which tells you genetics has a role to play in how people respond to training. But here's where we are right now. If you look at the United States, starting in 1994, going up to 2015, this says this is the amount of overweight, the people who have a BMI greater than 30 kilograms per meter squared in 1994. So you see this is less than 14%, and the most was here was around 14 to 18%. Then you see 2000, then you see 2015. 2015, majority of the states are 22 to 26%. That changed, and if you look at the same thing, diabetes, you have similar pattern because of the association between type 2 diabetes and obesity. And so what you have, this cannot be genetics. That's 20 years, 21 years. Genetics doesn't work that fast. Okay? It can't. You're talking about several generations. So when you got that big of an increase in obesity and that big of an increase in diabetes, you can't say, well, that's genetics. It's not. It can't be. That's just too fast. So the prevalence of overweight and obesity in the last 60 years, it's too fast to be caused by genetic effects. It's more related to a positive and chronic energy balance. You eat too much, you eat the wrong things, and you're inactive. That's lifestyle. I pointed out that there's a genetic predisposition, but lifestyle is much more important in this case because in the case of obesity, you eat too much, you eat the wrong kinds of food, and you're not active. You've got a chronic positive caloric balance, and you put on the weight. One problem, though, in looking at this is that people overestimate what they do and underestimate what they eat, so they don't see a problem. You know, oh, I go swimming every day. Well, they sit by the pool and play mahjong, you know, but they're at the pool every day. Or I don't eat very much. They're noshing things. They don't see a problem. Why am I gaining weight? I don't do that. I exercise and I don't eat that much, but in fact they do. And so that's where the part of the problem that they just don't understand it. So I'm going to tell you about a study done by one of my colleagues. It's a 100-day overfeeding study. This was done at the University of Laval in Quebec City. And the university had a house, a big house, was given to the university by a very wealthy person. And it was so far north and so isolated that the nearest house was 50 miles away. There was nothing for 50 miles in any direction. So they brought these identical twins, 12 pairs, age 21. They were around 11% body fat, so they weren't heavy, they weren't fat. They had them available for 120 days, 24 hours a day, and they controlled everything they did and everything they ate. So they had 2 weeks to say, how much do I have to feed this particular person? Each one was different to maintain their weight. Once they determined that, then they fed them 1,000 calories a day more. Okay? So I'm normally eating 2,000 calories, all of a sudden I'm eating 3,000. And they kept them sedentary. And there was no place they could go to do anything, so they kept them pretty well isolated. Look at the difference in the response. It went from 4 up to 14 kilogram increase. These are low responders, these are high responders in this particular case. The average was 8 kilograms. That's a big variation. So when the person goes to the physician office and he says, you're not doing what I ask you to do, there are people who respond differently. And you as someone maybe as a personal trainer or as a dietitian or as a physician or a nurse or whatever, you have to realize that people are different and they respond differently. So here was the average was 8. But so what Bouchard did then, he took each set of twins. So he said, here's a twin that really responded. And his brother was like this. They were similar. So there was a lot of variation from one twin pair to the other, but within the two twins, they were much more similar in how they responded. So that tells you there's a genetic effect and how they gain weight. Now, interesting though too, is the composition of that weight. It was actually 8 kilograms, but it varied from 4 to 13. So fat mass was about 5.4. The fat-free mass, the muscle and the bone, is 2.7, which is a ratio of 2 to 1. Okay? But it varied. The range was from 1 to 4 to 4 to 1. So for every 1 kilogram of fat that you gained, you increased 4 kilograms of muscle. These people, for every kilogram of muscle they gain, they also gain 4 kilograms of fat. That's a big variation in how people respond. Okay? The interesting thing is, those who gained more weight were the ones who gained more fat. They had a lower resting metabolism, so even at rest they were using less energy. They had a higher respiratory exchange ratio, which is an indirect estimate of whether they're using carbohydrate or fat. If you have a high respiratory exchange ratio, you're using more carbohydrates and you're conserving your fat. And all three of these studies have shown they have a high genetic factor. So how much weight you gain when you overeat and what the composition of that weight gain is influenced a great deal by genetic factors. So then Bouchard did another study, same location. This was a negative energy. They had 7 pairs of identical twins, 21. They were a little bit heavier, fatter, 21%. They were available for 117 days. They kept their energy intake constant, but they had them exercise 90 minutes a day for 100 days. Okay, so now you're keeping your intake is the same, is constant, but you're doing more exercise, hour and a half a day. So this is just a summary of the two. So you see here, if this one twin lost a lot of weight, so did the other twin. If this one set of twins only lost 2 kilograms, and the other one only lost about 1 kilogram. So you have this. This is the same thing with the other group. So you see that identical twins, they tend to respond similarly. So whether it's gaining weight or losing weight, in this case, almost all the weight that was lost was fat. But in the gaining, they gain fat, or some can gain more muscle and others gain more fat. So there's variation.
Did they participate in the same type of exercise?
Oh yeah, it was all on the bicycle ergometer, so they controlled exactly what they did.
It was as long as the expenditure was the same.
Yes.
It didn't. Okay. All right.
Yeah. So they all did the same level of work, and so 90 days. Yes, ma'am.
Do you use males because there would be more variation with females, or why are
No.
studies with females?
There was a twin registry in Laval that they had been doing studies on twins, and they had these people were more available, and so it goes back. You do have some more variation due to menstrual cycles and that sort of thing in females, and so the initial studies were done just in males to eliminate as many extraneous factors as they could. And later on, I don't think no one's done this with women. I think you'd find pretty much the same thing. It's just that when this was done 30 years ago, okay, And then there really weren't a lot of studies done on women, as you know. Okay. So if we look at a number of different estimates of how much the enzymes, it's muscle enzymes is fairly low, insulin, blood lipids, blood pressure, fat, resting metabolic rate, that's fairly high, but your body fat is here, your blood pressure is only 30%. Why is it there? Because if I'm under stress, or I'm overweight, or I eat a diet with too much salt, my blood pressure can go up or down. So it's environment more than genetics. So each one of these things has a combination of genetic and environmental aspects. So we say to people, all right, I'm going to give you, we always say, if you're more active, you'll be healthier, right? You've heard that many times. But when you look at it and say, what is the change in various risk factors, and what is the change in VO2 max? In other words, if I become more fit, do I become healthier? That's true in a group. The group that trains tends to be healthier than the group that doesn't train. But what's the relationship between how much I improve my fitness and how much I improve my health? Is not. So here you see, for example, blood pressure, 0.01 in women, 0.1 in men. That's nothing. There's no correlation. Triglycerides, same thing. Cholesterol, absolutely no correlation between your improvement in change in fitness and your change in that particular risk factor. Fasting insulin, fat mass, there was a little bit higher because the people who trained more, who improved more also trained more, and they burned up more calories. So, but even that's not very high. So the question is, why isn't there a higher relationship? The reason is this gene affects VO2 max and how I respond, or this set of genes, and this gene or this set of genes affects my cholesterol. They're separate genes. So not necessarily does this affect this or vice versa. So in a group, I will make more improvements. For an individual, and I do training, I improve my VO2 max. That doesn't mean I'm going to lose any weight. It doesn't mean I'm going to improve my cholesterol. All right? And this is where one of the problems is, because someone comes to a health club and they say, I want to lose weight. Maybe they're a person who doesn't lose weight. The twins didn't do it, and they were exercising 90 minutes a day for 100 days. You got one set of twins, they didn't lose any weight. Maybe 1 kilo over 190 days. There are people who don't lose it. Okay? And so the problem is, if I'm a personal trainer and I'm trying to convince you that you come to my, you're going to lose weight. I can't promise that. I can't promise that you're going to increase your VO2 max. We have high responders, we have low responders, we have average responders to VO2 max as well. So you got that variation in VO2 max, you got that variation in cholesterol change, you got that variation in lipids and blood pressure, all of these things. So you can't predict. You can do it for a group because people who are more active tend to be healthier. But that's 10,000 people, but if you get any 5 or 6 people, and this is what you do if you're a master's student, you do a study. We did this particular study that I was involved with, we started out with 800 people, families, and we wound up with 746. And they trained under supervision for 21 weeks, and we only took the people, 20 weeks, and the people we took for any of our analyses were only those who did at least 57 of the 60 training sessions. So we didn't say, well, this person didn't improve as much. Yeah, but he only did 50 sessions. When you start out with 800, you can eliminate a few of those, and you still wind up with people who did at least 95% of the training load. So we know that they did the program because they were supervised by us in the laboratory. Okay? But I can't predict who's going to be a high responder and a low responder. The only way you can find out is to say, train you, see who responds. Now, we also have looked at, and we can find a set of genes that tend to tell us more about that. And in the case of improving your VO2 max, we found 21 genes, but each one has just a small amount of thing. So you take, if I only had 3, I get that much improvement. If I have 5, I get that much improvement. If I have 7, I get that much improvement. If I have 9 or 10, I get that much improvement. If I have 18, I have that much improvement. But there's no way of knowing for any given individual how much they're going to improve, because not everyone that had all 18 genes improved a great deal. There's a lot of variation even in that part. So, for example, this is the distribution of HDL cholesterol. You see the variation. There's some people that got worse and some people that got better. Normally, if you look at the average and they say people who are very active have a high HDL cholesterol. Yeah, but if you train them, and this is from 7 different studies, well, this is actually just the heritage study. You see there's some people, I told you they were high, medium, and low. They're also adverse responders. People who don't respond the way you think they should. They trained, but they got worse. The fasting insulin is supposed to go down. Well, there were a few who did. A few had no change, and there were a few who actually went up, which is an adverse response. The triglycerides, there were people, normally you would think it would go down. On the average, it didn't change very much, but you had some people who had the resting systolic blood pressure, you would hope it comes down. A lot of them it did, but in a few it didn't. So here's a group where you actually had an adverse response. Just the fact that you train someone doesn't mean they're always going to improve. And so we looked at our data, and 7 other studies, and what we did, we looked and said, in fasting insulin, how many people had an adverse response? And so you see it's around 10 or 15%, around 10%. How many had an adverse response in HDL? Well, it's a little bit higher. It's up around 15%. How many in fasting insulin? Around 10%. How much in blood pressure? About 10 or 12%. So you've got a group of, when you get a large number of people, not everyone responds what you think they're going to do. So they have high, average, low, even adverse. That's just the variation that we have. That's why you do large studies. That's why you try to do randomized control studies, because you don't allow people to check where they are, because they maybe know that they love exercise and they're going to respond well. But you have to do it that way. So you as a student, if you want to do a research project, you take 10 people. You don't know if you've got high responders in one group and 10 low responders in another group, and you'll say, well, for example, men train better than women. You do the study again, now you have more high responders in the women's group, and you say, oh no, women train better than men. You do it a third time, there's no difference. You put all 3 together, you'll say, probably there's no difference. And what we found, but I'm not showing here because of the time, we found no difference between men and women in the distribution. There were high and low responders at all ages. No difference between blacks and whites. We found no difference between 18 to 65 years of age. So age, gender, race had no effect. There were high and low responders in every group. There's just that variation that we have, and that's why it's nice if you have genetic disease like cystic fibrosis, you can say, I have this missing gene or defective gene, I get cystic fibrosis. But their genes are so different. And all these people that you study, so we studied families, so we had the mother, father, and at least 2 children. So when we did the genetic study, we had comparisons between the parents and the children, and with the children, and that sort of thing. And these are the kinds of things that we found. So what's the message? Phenotypes are complex. It's a simple thing about height or weight or VO2 max. Those are complex phenotypes. How many things do you think can affect VO2 max? My respiratory system, my cardiovascular system, my muscular system, my enzyme system. All of these things, each one have different genes affecting them. So you can never find one gene that's going to tell you everything. So you wind up having to get 25 or 30 genes, and each one will tell you a little bit. So there's a genetic influence, but you can't predict ahead of time because it's just too many. They're complex, they're influenced by many other genes, there's interaction among the genes and between genes and the environment. So genes are important, But for the majority of problems that we have, it's lifestyle problems, not genetic problems. We eat too much, we do too little, and we have those problems that are associated with lifestyle, much more than genetics. Not everyone responds the same way to exercise or any other change in the environment, whether it's diet, whether it's medication, whether it's exercise, whether it's anything else you do to change someone, not everyone responds the same way. And non-responders are not necessarily people who don't adhere. Remember I told you in the Heritage study, everyone trained at least 57 of the 60 sessions. So we know they did the program. They adhered to the program, but our average increase in VO2 max was 19%, which is very typical of what you see in exercise programs. But it varied from 0 to 50%. That's a lot of variation. But when you read research, they just tell you the mean and the standard deviation. They don't tell you the distribution. And so you see, we had people who do not respond whatsoever and those who are really high responders. But the average was 20%. That's very typical. But we had 800 people, 700 people, and we can look at it and get a better idea. So many genes can be involved that a non-responder for one phenotype may or may not be a responder for another. That's what I mentioned earlier when I said, you come into an exercise program and I want to lose weight and I want to improve my blood pressure. Well, you may improve your cholesterol, you may improve something else, but you're not improving the things that you want to do. And so that makes it difficult if you're a personal trainer or a physician or a nurse or a dietitian. You say, I want to give you this program, but you can't guarantee that they're going to get that. That's why I don't like to call, they're called fitness clubs. I like to call them health clubs. I can't guarantee you're going to increase your fitness. I can guarantee if you're active, you'll probably improve some factor of your health, but not all health factors. So I call them health clubs. I prefer, but I don't own them, so I don't have any say in that. But I wouldn't call them fitness clubs because you can't guarantee that they'll be fit. Now, low fitness and inactivity are independent risk factors. How fit you are and how active you are, as I told you before, they're not related. They're independent risk factors for coronary heart disease and the overall mortality, so the people who are more fit and more active tend to have less disease. But the two are not necessarily, they're independent, associated but independent. But fitness is more affected by your genetics. Your lifestyle, activity and lifestyle modification is the environmental side. So if you're lucky and start out with a good genetic background and you're a high responder, you'll have a lot of success or some success in athletics or sports. But the guy who is starts out genetically low and is a low responder and trains and trains and trains and trains and nothing happens, he's there too. And you just don't know how people are going to respond. So activity and fitness is not the same. So this is a comment that a colleague of mine made many years ago. He said, the process of being active is more important than the product of being fit. I can't change my genetic background. I can't pick my parents better next time, right? So what can I do? I have to change my lifestyle. I have to modify my lifestyle such that I become more active. That's more important. I don't know what's going to happen if I become more active. I'll enjoy it hopefully more, and I'll see some changes that I think are good, and I'll feel better about a lot of things. But concentrate on being active rather than concentrate on being fit, because you may or may not get more fit. So it's a regularity of physical activity is important for reducing the problems with lifestyle. You can't change the genetics. You may have a genetic predisposition, but you still have to use the lifestyle to modify the risk factor. So you need to think less about fitness and more about activity to improve your health. And there are many ways to do this, so just find what you like to do and do it regularly. People say, what's the best program? I say, what will you do? The body doesn't know whether you're walking or cycling or rowing. It's the idea that you're doing something on a regular basis and that's it. I don't think you're always getting the new program, the next program, this dietary program, everything in moderation. Do what you like, but do it and make it part of your lifestyle. Then your genetics, you have no control over that anyway, so don't worry about it. So we still have a lot to learn, We're only about here. There's still a lot there. So I just want to give you an idea that genetics is important, but it's not the only thing. And for the majority of problems that we have, it's lifestyle. So it means you've got to change lifestyle and think of activity rather than fitness, which is influenced more by genetics. Thank you very much for your attention. And I'll be glad to try to answer any questions you might have. No questions. It was so clear. Isn't that nice? Yeah.
Well, first of all, thank you. Thank you for your disseminating this type of information. I think it's useful, so thank you very much. I'm thinking back to, in my previous lifetime, I was a member of the faculty at Duke, and I was a co-I on a study looking at whether or not one's knowledge of genetic predisposition to a particular chronic disease, in this case type 2 diabetes, had any impact at all on health-changing behaviors.
Probably did it?
Yeah, so what happened was we recruited participants from primary care clinics that were not yet diabetic, but certainly pre-diabetic.
Yeah.
And they were randomized into two groups with me. One of them was we looked at a particular gene that we screened for.
Yeah.
And basically, it was just me explaining to me that genetic predisposition. The other group that was assigned to me was basically me being a health coach. And when we brought the two groups back, they only, in terms of the biomarkers that we were following for, which is basically weight, BMI, blood pressure, waist circumference, serial A1C levels, only slight improvement in both. Maybe a little bit more on the health coaching side. And we surmised that was only because they got a chance to meet with a human being instead of just having a piece of paper thrown at them about prioritization. But your idea about the responders, I don't think we controlled for that.
You don't know how to control. The way you control for that is to have a large number of randomly assigned people. Because otherwise, you get, if I were to take this half of the room and then that half of the room, and you've got more high responders for whatever you're looking at and more low responders over here, you come up with the result that, but that's one of the advantages of meta-analysis is that you can find 5 or 10 or 15 studies that have tried to look at this thing, and if you see a consistent pattern that this group is better than that group, then you've got something. But for 10 people, you never know. And we know that knowledge is not necessarily followed by action. Because people know they shouldn't smoke. People know they should lose weight. People know they should be more active. That doesn't mean anything. I mean, it means something, and it'll mean more for some people than others. But basically, we're not doing a very good job of convincing them that they need to change their lifestyle. But part of it is we can't tell them what's going to happen. All we can say is, try it, do it, make it part of your lifestyle, and there are going to be some improvements, and your health will be better. I just don't know which aspect of that is going to be what works for you. But if my goal is losing weight and my weight stays the same, then as far as I'm concerned, you failed as a personal trainer or as a health coach. Because that's not what I wanted. Well, I can't, you say pick your parents better next time, but you can't do that either. Yeah.
Some of our students are interested in health coaching certification. Do you have one that you're aware of that would be a good one to engage in?
There is the National Association of Health and Wellness Coaching. And now ACE, the American Council on Exercise, has just started, and they're the only one right now outside of that group, mainly for personal trainers, but dietitians and the other. And they are just starting a program, and the book just came out last week, as a matter of fact. It's in digital form, and you go to ACE and you can get it from there. It's a book on health coaching, and it's to get the people to read it and take it, and then they could take the exam and become a certified health coach with the American Council on Exercise.
Okay, thank you.
Yeah. Yes, you had a question?
I was going to ask you, in the genetics study, did you controlled very well for exercise, but did you control for their eating habits or no?
In the heritage study that I was telling you about, which, by the way, is the largest study ever funded by NIH with exercises, I think it was $40 million over 12 years. Okay, so it was a big study. We had so many, we were asking these people to do so many things. All we did something called a food frequency questionnaire. And so we went to see if their pattern had changed at all. We also looked at their activity. There was a little bit of suggestion that some of the people who became more active in the gym or in the laboratory, because they did it on a bicycle ergometer, tended to be a little less active in some of the other parts of the day. So we don't know how much we influenced everything. I mean, it's not like everything else stayed the same, but we tried to control as much as we can, or at least get an idea of what was happening. And there were no major changes in anyone in their diet and all that, because we told them, this is what we're doing. It's for 20 weeks. And we were very lucky. Now we paid, this is different, we paid each person $1,000. Oh, wow. All right? But you had to have the mother, father, and at least 2 kids. So if the mother drops out, we have to drop them too. Oh, so then there's pressure on the mother to stay. And if it's only one child drops out, or no child drops out, there's no we don't think there's a connection between the husband and wife genetically. You know, maybe in North Carolina there would be, but not necessarily. You know, but we had to drop some families because 1 or 2 people dropped out. And then we had one family, for example, had 2 kids, but the young girl got pregnant 1 week before the study was over. But now we're going to be doing all these tests on different hormones and everything else, and she's pregnant. We couldn't use her data, so we had to drop her, and as a result, we had to drop the whole family. So we did pay them $1,000, but if we told them, look, it's nice to say $1,000, but if you figure out the number of hours we're asking you to be tested, we tested everyone twice on everything, then we trained them for 20 weeks, and if they missed a session, we called them up, said, you're behind one. They were never allowed to get ahead or behind more than 2 sessions. So if they were going away for a week, we said, okay, you come and train 4 times this week, and 4 times a week you get back, and then 4 times the following week. So you're getting your 3 a week that they had to come in. And so we said, if you figure out the number of hours, we're paying you less than minimum wage. What you're getting out of this is information. But now imagine when we get through, here's your $1,000, but by the way, you didn't lose any weight, which is what you wanted to do. And you had a high blood pressure, but it's still high. You need to go on medication. So, we didn't have an effect on that. But your cholesterol went down. Isn't that nice? And they started to look at you now. Yeah, well, okay, I guess. But, so that's the problem. You can't be sure what's going to happen. But there's a definite influence of genetics. It's just that there's so many genes involved and so many interactions between this gene and the environment, between this gene and that gene, and so there have been many, just to give you an idea, back in the early 90s, there were studies done that look at one gene and how it's related to physical fitness or VO2 max and that sort of thing. And they found a few studies did it, but they had 15, 20 people. When we looked at the heritage study and we had high responders and low responders, and we compared them, we found no difference in that particular gene. So, and you get all those number of genes, and you say, with a small group, you may find something. With a large group, we're not finding it, because there's so many genes involved. And so you can't look at one gene. Like I told you, just for VO2 max, you've got genes that are affecting all different systems of the body and how they interact with each other. So I can prove my lung function has no effect on some of the other parts. So it's very complex, but I think interesting. And so that means if you're studying that area like any other area, you got a job for a long time, because we still don't know a lot. I know a fair amount, but there's still, but hey, if you're a professor, you get paid to learn. That's a pretty good job. So, yes, sir.
So now, I'm going to say in this generation, you have a lot of kids that, I don't want to say born obese, but as they continue to be older, around 4, 5, 6 years old, they're a lot bigger than kids that are their age. Is there a way to, in a sense, do a study to see, like you said?
Oh, they've done studies, and they're saying this generation may be the first generation that lives not as long as the previous generation. And back in the 90s, it was very rare to find a child who had type 2 diabetes. Now with the amount of obesity, we have 10 to 15% obese and 9 or 10% type 2 diabetes at age 10, 12, and 13. And so they're at age 39, they're going to start having other chronic medical problems like heart attacks and that sort of thing. And so you've got to do something to change them now.
So is that, would we consider that still being genetic, or is that environmental being a?
Yes, both. Okay?
So this is.
So you've got that genetic, you may have the genetic predisposition, but also probably you're eating the same thing your mother and father and your people around you. And there were studies done of black women in Seattle a number of years ago, and they looked at what they were eating, and these were all women who were obese. And they looked and they said, for their peers were all obese black women, so they didn't see a problem. They said, I'm no different than anyone else. That was the problem. They weren't different than from anyone else. And so their group that they were looking at, they weren't any fatter than the other people. And so they didn't see a problem. Okay? Perception is very important. And if you don't see a problem, like I said, people overestimate what they do and underestimate what they eat. So they say, well, I don't see why I'm putting on weight. Or I tried to lose weight and I can't. Well, maybe they're that kind of responder and maybe they're not. You don't know that. And that's where the problem comes in. It's very complex, but we're getting to the point where so many people are overweight that it's, we used to be number one. We're number two now. Mexico is number one. China's getting to the point in about another 10 years, they'll be in the top 2 or 3. I went to China the first time in '88, and at that time they had millions of bicycles and very few cars, and the people were lean. Now you go and you see very few bicycles and you see thousands and thousands of cars, and people are getting overweight. Plus, they're bringing in Kentucky Fried Chicken and McDonald's and all of that, and they're eating the way we eat, and that their obesity rate is going just like that. So it's lifestyle. Lifestyle is much more important from our health standpoint. Don't worry about your genetics. You can't change that. Worry about your lifestyle. Thank you.
Thank you.